Hello sir, this is Rishik of registration number 19BC1494 recording this video for machine learning Da2. Today I'm going to explain a priori algorithm. A priori algorithm is used for finding frequent item sets in a dataset. Uh, it is named a priori because it uses prior knowledge of frequent item sets. The a priori algorithm uses level-wise search where k item sets are used to explore k plus 1 item sets. In this algorithm, frequent subsets are extended one item at a time and to generate the candidate item set. Uh, then a group of these candidates are tested against the data, and then it identifies the frequent individual items in the database and then extends them to a larger and larger item sets as long as those item sets appear sufficiently often in the database. A priori algorithm determines the frequent item sets that can be used to determine association rules which highlight general trends in the database. The a priori algorithm takes advantage of the fact that any subset of a frequent item set must also be a frequent item set. The algorithm can therefore reduce the number of candidates by considering and exploring only the item sets whose support count is greater than the minimum support count. All infrequent item sets can be pruned if it has an infrequent subset. So how do we do that? First, we build a candidate list of k item sets, and then we extract a frequent list of these k item sets. Then we use the frequent list of these k item sets in determining the candidate, and sequently the frequent list of k plus 1 item sets. How do we do that? We use pruning to do that. That is, if in the k item sets, if any of those do not match the support count, we prune them. Similarly, we'll repeat this process until we have empty candidate or frequent sets, and then we return the previous list of item sets. That is, if uh, we get it empty at k item sets, then we send the k minus 1th item set. The key concepts here are frequent item sets, the a priori property, that is any subsequent frequent item set must be frequent, and then the join operation. This is the a priori algorithm pseudocode. You can see. Now I'll explain it with an example. Yeah. So the following data set, and we will find the frequent item sets and generate association rules for them. This is the data set. It has 9 transactions, and for each transaction, the items are I1, I2, I5, etc. So it has 5 unique items, which are I1, I2, I3, I4, and I5. The minimum support count for this equation is 2, and the minimum confidence is 50%. Minimums basically support is nothing but the frequency of occurrence of this item in the dataset. In the step 1, we create a table containing support count of each item present in the dataset called the candidate set. So this is the candidate set. Here the item sets are the items present are I1, I2, I3, I4, and I5, and this is the support count of these. And then after we generate the candidate set, we compare the candidate set items support count with the minimum support count, and here the minimum support count is 2, and as the support count of all these is greater than or equal to 2, we do not prune them and get the item set L1. After that, we generate a candidate set C2 using L1. Uh, we do so by joining LK minus 1 and LK minus 1. That is, it should have k minus 2 elements in common. That is because basically this is it has one item each in like in each row. So basically the next will take two items. So we can generate like check all the subsets of an item set are frequent or not, and if not frequent, remove the item set. So basically what we generate is the item sets I1 I2 is taken as one item set, then it could be I2 I3 as one item set, etc. And then we generate and we check if its subsets, that is I1 I2. So for this set I1 I2, the subsets are I1 and I2, and we check if they are frequent. So here they are frequent, none of them are prone, so we consider it. So after we consider it, we find the support count for these item sets. So for I1 and I2, support count is 4. How it is 4, we can check it here. Here I1 and I2 are occurring, I1 and I2 are occurring here, I1 and I2 are occurring here, and I1 and I2 are occurring here and here. So it occurs, this set occurs 4 times. So its support count is 4. So similarly, we can find like this. And after we create a candidate set, we compare the candidate set support count with the minimum support count. The minimum support count is 2, so therefore the minimum support count of I1 I4 is less than 2, which is 1. So the minimum support count of I1 I4 is 1, which is less than the minimum support count, so we prune this. Similarly, I3 I4 occurs 0 times, so its support count is 0, so we prune it. I3 I5 occurs once, but the minimum support count is 2, so we prune that as well. So finally we get the item set L2, which consists of I1 I2, I3 I5, I1 I3, I1 I5, so on. After that, we generate candidate set C3, which should consist of 3 items in one single set. So we'll consider the item set generated by joining L2 is I1 I2 I3, I1 I2 I5, I1 I2 I3 I5, I1 I2 I3 I4, I2 I4 I5, I2 I3 I5. Now we check whether these are frequent or not. So if to check whether they are frequent or not, we should see if their subsets are frequent or not. So if, for example, if we take I1 I2 I3, its subsets are I1 I2, I2 I3, and it's I1 I3, and that's it. So we check if I1 I2 it is frequent, I1 I3 is frequent, I2 I3 is also frequent, so we consider this. And similarly we'll check for all of them. uh, for example, we pruned I1 I4 here, so if we check for if we check for the set I1 I4 I5, we do not find it here because its subset, that is I1 I4, is not frequent, hence these are only present. Now we'll check if all the subsets of these item sets are frequent or not. Here subset of I1 I2 I3 are I1 I2 I2 I3 I1 I3, which are frequent, and for I2 I3 I4 subsets are the subset I3 I4. Yeah, we don't have I3 I4 in this, so it is, as it is not frequent, we remove it. So I2 I3 I4, so this is removed. Similarly we'll check for everything, and finally we end up with I1 I2 I3 and I1 I2 I5, and the support count of these are 2. And after the support count is found, now we can compare this candidate set to support count uh, with minimum support count. Here the minimum support count is 2, and as their support counts are equal to 2, we don't prune any of them. And after that we generate candidate set C4, which would consist of 4 items in one set, uh, 4 items in one set, and its subset contains I1, I3, I5, which is not frequent. We proved it in the before step, and therefore we don't have an item set C4. As we have found out all the item sets, all the possible item sets, then we go along with association rule. So in association rule, we calculate the confidence of each rule. So basically, confidence is a confidence of 50% means that 50% of the customers who purchased milk also bought butter, and confidence of A and a confidence is calculated by support count of A union B divided by the support count of A. So here, if we take the example of like we have two, so we'll take the first item set I1, I2, I3. So if we take I1, I2, I3, we can generate the confidence by support count of I1 union I2 union I3, so which is 2 divided by the support count of I1 I2. Support count of I1 I2 is 4, so it is 2 divided by 4. So 2 divided by 4 into 100, which is 50%. Similarly, if the person buys I1 and I3, what is the confidence that he'll buy I2? Similarly, this is we have seen above that this is 2 and this value is this value is 4, so it is again 2 divided by 4, and which is 50%. Similarly for I2 union I3, the confidence of I1 would give 50%, and what is the confidence that if a person buys I1, what is the confidence that he'll buy I1, I2 and I3? So the confidence of this would we calculate it by I1 union I2 union I3 divided by the support count of I1. So the support count of I1 union I2 union I3 is 2, and the support count of I1 is we calculate in the first step, which is 6. So therefore it would be 2 divided by 6 into 100, that is 33%. Similarly, we can find for I2 and I3, and if these are the confidence sets, the confidence values. So if the minimum confidence is 50%, then the first 3 rules can be considered as strong association rules. We have seen the example, now we see an implementation. So this is the dataset that I am taking. It is a grocery store dataset. It has 10 items. It has 10 items with 20. It has 10 items with 20 transactions. So as you can see, if we go to statistics, so if we take the example of bread, of item bread, so it is false 7 times and true 13 times. That is, out of the 20 transactions, this bread has occurred 13 times and it has not occurred 7 times. So we feed this data set. This is the retrieving, so I'm taking the data set. Now I'll convert it, the data set from nominal I'll convert it from nominal to binomial. So now I'll feed the data set to this. This will convert nominal values to binomial values, and after it converts it to binomial, now we'll use FP growth. So what FP growth that does is it basically calculates the frequency of the item sets. So if we go to in the help, if we read the description, during online shopping, uh, you you sometimes will get a suggestion that customers who bought this item also bought this item, which is basically association rule. To derive the association rules, we have to know which items are in the market are most frequently occurring in customers' baskets. So we'll use the FP growth algorithm. So what FP growth algorithm basically does is it is an algorithm for calculating the frequently co-occurring items in a transaction database. You can read all the theory here. The NFPT can be created compressing the data. So it has, this is the documentation for it. So the output is, it takes the input as binomial values, and it gives the example set that is given as input is passed through without changes. It gives the frequent item set. The output would be the frequent item set. That is, it basically calculates the support count for each of these. For each of the item sets, it also prunes the item sets, and then it it just gives the frequent item sets. So after the pruning and all is done, then we use uh, association rules to create association. So when we after we feed the frequency to it, then this module what it basically does is it creates the association rules for us, and then we feed it to this. It gives us the uh, output, final output. So here I fed the binomial data set to FP growth, and after that I fed it to FP growth output frequency to association rule, create association rule module. So in the FP growth, you can see that we can set a minimum support count for, we can change the minimum support count, we can change the minimum requirement. There are different things we can change, and even in the association rules we can change the minimum confidence, etc. I would like to change it to 7, and after we change it we just basically have to run it, and it gives us the output. So this is the premise and this is the conclusion, this is the confidence. So you can see it has already calculated the confidence value for like this is for a single item set, and then it is for like Bonvita, sugar and milk, etc. It also generates a graph. uh, it's read to it's difficult to read the graph. We can go to description. It description shows us all the association rules which have a confidence of uh, greater than the minimum confidence. Minimum confidence which I gave was 0.7. So it gives us all the association rules which have achieved a confidence greater than 0.7. So the association confidence for tea and biscuit is 0.7. The association confidence for milk, biscuit, coffee, along with when these are bought, uh, what is the confidence that sugar is bought is it's 0.8, and the confidence that milk is bought when Bonvita is bought is 1. uh, the confidence that when someone buys biscuit and sugar, they will also buy milk is also 1. Similarly, we can check all the confidences and the association rules for this for the data set. The tool that I used is RapidMiner Studio. It is easy to visualize in this, and it is easy to get. It is easy to design the model as well. So that's why I picked this. Um, thank you.